Okay, hello everyone, and welcome to our third of our four-part webinar series, which is called Simulation in Maritime Safety Training. Basically, we've covered and will be covering what you need to know before adding simulation to your training program. If you haven't joined us before, I'm Allison Crawford. I'm the marketing specialist here at Virtual Marine, so I will be your host today. Just a few housekeeping items before we begin. Hopefully your speakers are great. Both Randy and I are tuned in via video and speaker. If you have any questions or comments, if you could put them in the chat pod in the bottom right corner of your screen there. Randy will go through his presentation and then we will take questions after the fact. The webinar is being recorded, so if you have to step away or if there's someone that you would really like to see the video after the fact, we will invite you to let us know and we can send you a link to the video of this webinar when we finish. So we are going to get right to it. So I'm going to introduce Randy Billard. So Randy is the Chief Technical Officer here at Virtual Marine. He's also Executive Vice President. He's responsible for leading Virtual Marine's team of engineers and computer scientists in the continuous development of small craft simulation technologies. He has expertise in military and civilian simulator development and project management, and he's actively involved in the ocean engineering and simulation R&D communities. He has experience in managing technical product development from early stage prototypes to commercially ready systems, which includes the validation and testing of simulators at various technology readiness levels, TRLs. He is a certified professional engineer. He holds a bachelor's degree and master's degree, so bachelor's degree in mechanical engineering and a master's degree in ocean and naval architectural engineering from Memorial University of Newfoundland, with expertise in vessel and wave modeling. Randy has conducted several academic and industry-led simulation studies, some of which you may see as tidbits of here today, and has authored and co-authored conference and journal articles on the topic of simulation. So without further ado, Randy, I will ask you to take over and you can begin your presentation for today.
Okay, thank you, Allison, and thank everyone for attending. I hope everyone is doing well and staying safe. So as Allison mentioned, we're going to talk about a couple of things today. As a group that's providing simulation and building simulation to teach people how to operate small craft and other vessels in the marine world. We've done a number of studies, both internal with our clients, to look at this, how we can take people to the next level in their training, given that they're able to now, given things like lifeboat simulators exist. So we're going to talk about some of the factors that we think are most important in simulation learning and what we're doing to create competence in both our trainees and our clients' trainees as they implement simulation. So we're going to tell a few stories today. I'll be the traditional Newfoundlander in that sense, and I'm not an experienced mariner as most, but I've heard a lot of mariner tales, and I'll try and bring as much of these stories that we have in our world of simulation to people here today, so they can apply some of our lessons learned and some of some of the neat things we're doing as a technology and training company to their applications. Some of the questions we're going to cover today are important to us, but also anybody who's in the marine training world. How are we assessing competence? How much practice is needed to become competent? How do we prepare people for actual emergency situations, given that that's been a limitation in the past? And what can we do to speed time, get them ready and speed time to competence? As Allison mentioned, we've done a lot of studies. Some are academic based, some are with our clients, some are internal, and we're learning lots of lessons. We certainly have been over the last 15 years that we've been doing this. Lots of lessons about people, lots of lessons about technology, and we're trying to embed as much of our expertise and our clients' expertise and the experts' expertise into our simulations, so we can create a better training experience. And that's what we hope to get across to the team today. And if you got, we'll talk and we'll get questions after. If you have any questions throughout, just post them, and Allison, we'll address them at the end. So first question, how are we assessing competence? So I'm not going to get into a big pedagogy discussion or big theoretical discussion of what is competence as such. Just to simplify it for anybody, how do we make sure people can do what they're expected to do in a real operation as they are in training? And there's lots of good definitions out there, but can you do what we expect you to do, and when you need to do it? And this has been the challenge, but also the outcome is that most of the training that's gone on in lifeboats is for good reason, for the safety of people and for the safety of equipment, is performed in calm water. So a lot of groups here are using training facilities or being in training facilities where you take a lifeboat, you launch it into a harbor, and you do your exercise. And that's a safe way for you to do your training, of course. It's good. It's a good way for you to become familiar with the boats and the procedures and such. And then the expectation is that whatever you learn in that training program, you can apply to a situation like you see on the right picture here, which is a plausible situation offshore, in offshore Canada, offshore Norway, or anywhere where there can be treacherous weather. You may have to launch that lifeboat into a 5 or 6 or 8 meter sea. You might have lots of wind, you might have low visibility, and you could also have things go wrong and have hazards to deal with, fires, explosions, these sorts of things. And the expectation is that whatever you learn in training, you can take with you into these emergencies. Now, obviously, there's a bit of a gap there, but this is where we see simulation being an excellent case. You don't teach a pilot how to land a plane with broken landing gear in a real plane for the first time. You put them in a simulator, and they've been doing that for years. And these are sorts of things that we hope to do with things such as lifeboat simulation. Put you in a safe environment where you can learn how to do things in such as launch a lifeboat into a 6 meter sea, 10 meter sea with winds and such, and you can at least recall those experiences to save yourself and your crew. So assessing competence of how do we expect people to perform in these types of environments? That's what we're here to explore and talk about today, and that's what we'll get through. So we've done a number of studies, and I'm going to speak to a few today. These have been industry studies to assess how current training regimes, what college people are actually getting, what results people are actually getting, and then what can we learn to improve training. So I'll just tell some stories on this one. So one of the studies we did was an industry sponsored study. Wanted to see how skills that were learned in initial training, how they were retained, and how much training people actually needed to maintain their skills. So we took a group of participants. We ran them through a training course, representative of what they would get in regular training, offshore training. And we brought them to competence, and then we let them go for 3 or 4 months, or 3 months, and then brought them back and tested them. And we did that 3 times. So that emulates the training that someone would get over a year if they were doing regular drills on an offshore platform. So the expectation is people, once they're gone through the training, that they're ready for an emergency. So one of the outcomes that we saw is that after their initial training and having to launch that lifeboat 3 months after the initial training, we had less than 20% of people who could actually do it. And in this lifeboat exercise, there were 10 or 12 steps that people had to do. And each, a lot of those steps, and each of those steps could result in damage to the equipment, or damage people inside the lifeboat. If you forget to start the engine, you'll drift in the water. If you forget to tell your crew to buckle in, then when you hit the water, they could be tossed around. And if they didn't do those things right, we didn't call it a successful launch. So that was one of the things we found, that after 3 months and so then we trained them again after 3 months, and we did that 3 times. And then it actually took 9 months of regular practice. So it was once a quarter for 9 months for 80% of the people, above 80% of the people, to demonstrate competence when they had to last light for the first time. So that tells us one thing, that there's an outcome of initial training and what's being taught, and then that just promotes the case that you got to train more regularly, get frequent practice, and keep those skills maintained in order for you to be ready for these. This was a calm water launch. What we drilled in this, it was emulating a launch drill. So even for a calm water launch, it took that much time for people to be ready, as we call it. That's one of the studies we did. Building on that study, we did a transfer study, and in this transfer study we also evaluated or compared the different types of training that people got or have access to today. So it was the same formula. We gave people initial training. And then we trained them one of three ways. We trained them either with live drills or drills which were representative of people doing offshore regular drills, people doing classroom or CBT training. So if there are some groups that are not performing regular quarterly drills, they're refreshing their knowledge with either CBT or running through operating manuals of the vessel. So that was group two. Group one was live drills. Group two was classroom, and group three was a simulator, which was a new alternative that came on over the last 5-10 years. And we just wanted to see how people who were trained regularly, once every 3 months, how the skills that they learned in their training was transferred to a plausible emergency situation. And that plausible situation was it was a moderate to high sea state, 3.5 meters, but it was in a reduced visibility, and they had to basically had to launch a lifeboat into and get away from the oil and gas platform. So it was an expected exercise for an emergency. I guess there were lots of outcomes from that study, but the two of the key ones that we saw was first, anybody who didn't get or didn't receive hands-on training, and that's actually reaching out and touching the physical controls of the lifeboat, either through a simulator or through using the boat in live drills. There was not one person in the group that could launch that lifeboat successfully in the first time. So there are lots of explanations for that, but basically, it comes down to they didn't get enough muscle memory for them or procedural memory to figure out how to launch that lifeboat after in an emergency. So that was a pretty low success rate. And then we compared the two groups that did get hands-on training. And we saw that the simulator group, who had done different exercises than just live boat training, just regular drills training. So in regular drill training, you just launch into the water, you do a calm water exercise, and you're recovered. In a simulator exercise, you can do a little bit more. You can change the sea state a bit, but you can also put people in scenarios which aren't repetitive. And by the way, one thing of note, there's published results we can share with you after if you want more information on this. And there's lots on this study. But what we found is that in trying to discern what happened here is that the simulator group behaved differently. They didn't treat it like a regular drill where they had to do the same thing over and over. They assessed what they had to do, evaluated their decisions, and in doing so, they were figuring out the problem. Versus the drills group who was just doing the same thing they had done over and over and over. So in the study, we had lots of things to learn there. How people trained and the types of scenarios that they were using was beneficial. But it promoted the big outcome was that there was a lot of value in hands-on training and actually using equipment that's representative of a lifeboat or a real vessel in these studies, and that's what really drove home the learning objectives. We've done lots of studies, lots of related studies since. A lot of the work we're doing now is assessing performance in human factors, or human performance in conditions which there's not a lot of data. So taking someone and putting him into a 3 or 4 meter sea state and asking them to pick up a man overboard, for example. I mean, there's not a lot of training data available for that because those aren't exercises people do with a live boat just due to the risk. So we're this is new territory. We're getting new information out of it, but it's also causing us lots of what do we expect and how do we deal with this new information, and these types of problems are coming in. We'll speak one in a second, but we also learn more about not just what's the limitation of the person, what's the limitation of the people when we put people in these adverse weather conditions. And this is new territory that we've been doing a lot of research on. We've been sponsored to do a lot of studies on how lifeboats perform in very high sea states, 8 or 10 or 12 meters, and what that translates into is what are the equipment limitations? What can we do to make sure that people are familiar with how to operate the boat in those situations too? And is there a way that we can enhance training so people can perform better than expected to increase their chance of survival? Because these are real conditions that people may actually experience. So I'm just going to break off. I'll give you a video of this is not our live simulation environment. This is a numerical study environment that we use to validate our lifeboats in a numerical world. And I'll just set it going. This is emulating an 8-meter sea, and this lifeboat is being launched from a davit. And I see my point. You see it. We got 3 markers put behind this lifeboat, and those are there intentionally because they represent 1 boat length, 1.5 boat lengths, or 2 boat lengths behind this lifeboat. And this wall that you see is the actual platform, or a barrier for the actual platform that a lifeboat could actually bang into. So you'll see as this boat gets into the water, they're going to. This is where timing becomes important. If you release your hooks, or you take too long to release your hooks, or you take too long to apply your throttle, what happens is that wave energy pushes the lifeboat backwards, and you'll see this happen in a few seconds. So the boat gets released, and that lifeboat goes back the 1.5 to 2 boat lengths, doesn't make contact with the platform, and then it's going to try and progress forward on that wave. This is a very plausible wave environment, especially in the North Sea and offshore Canada. And if that operator didn't do things correctly, the chances of them actually getting that lifeboat going forward in this type of sea is very low, and the chance that it hit the platform is very high. So building on those sorts of numerical study, we started putting people through human factor studies and training them. And I'll just give you an example. Here's a student going through this environment, and just so you know, we've exaggerated the environment quite a bit and made it a bit cartoony so they can do things such as time or see when the wave crest is coming forward and such. And their job is to launch the lifeboat where they think is the proper spot on the wave and go forward. This is the first time they were able to practice it. So just to show you, this was not a great launch. This person went backwards. He went into zone number 1, which was yellow. I was warning. Then he went into zone number 2, which is red, which basically means they came in contact or came in very close contact to the platform they were launching from. So this is an exercise they can now practice. And just to let you know, what we found is that there are ways that we can put people through training environments and get them to practice the timing of their release, and to do things that aren't traditionally done in practice, such as running your engine a little bit earlier before entering the water and such, where people can overcome that backward momentum and get the boat going forward quicker than or quick enough so they don't make contact with the platform. And this is the environment where we can train them right now. And so it was quite an interesting engineering cool sort of way to watch people overcome the equipment limitations and have the human factors and their experience overcome what would be if they follow procedure a bad outcome. So these are things that we do as we put people in these situations. We learn about the equipment, we learn about we learn about the procedures and what we can do to improve the launch procedures, and we embed these in the training programs and give people a chance to practice it. And this is just one of the examples of many, whether it's launching a lifeboat or picking up a man overboard in a 3 or 4 meter sea. These are all things that now you can practice, and we can learn we can learn things not just about what procedures work, but how much training is actually needed to get people to a level we call competent, so they're able to do what's expected of them in an emergency. Okay. So the last thing we'll talk about in these studies is what we're starting to figure out and starting to apply is, how can we improve the training experience, not just for the student, but also for the instructors who can use these types of technologies and trainings now. So putting people in 4 or 5 meter seas, 5 or 6 meter seas, whatever sea states you want to, dangerous conditions. This was territory we had to define a bit. How do we? The question that came back to the instructional team was, how do you expect people to perform in these sea states, and what do you expect them to do? How do you score them? And we basically had to work with subject matter experts and industry experts to come up with, here's what we expect them to do, and here's how we're going to score them, and build that into our training curriculum. We've done that's probably been our most iterative process over the last few years, is as we put people in these environments, how do we make sure we implement training that works and we're scoring people properly? And in doing so, we're gathering information on students and on a number of different skill levels, from novice to experts. It's made us move the yardsticks back and forth many times to define what an expert is, define what a novice is. But we can do it now because we're starting to gather data on it. And that's been a really big benefit for anybody who's putting people through these environments, is capturing data and figuring out where people fall on the scale, whether low or high, and then being able to adapt training accordingly. The instructors we've done a couple experiments with instructors to see what they see valuable in the simulator. And a feedback we get a lot is that especially in situations where instructors have to both monitor and measure and score and coach at the same time, one always falls. It's either you can't score consistently, or you can't coach as much as needed with the student. And we've done tests and such, especially when something like stopping next to a man overboard or a vessel. You got to stop the vessel in time. You got to stop it close enough to a man overboard. You got to make sure you're coming in from the right direction, and you've also got to take into account any other factors which might affect your performance. That's 4 or 5 different things that an instructor would have to look at in an assessment. And if they're looking at those 4 things while trying to coach the students what to do, what happens is one of those falls down. And this is where we say, one of the outcomes is, why don't we let the simulator score for you, and you focus on coaching. And that's been a big benefit here, is we can take, let the simulator do the simulator's going to score consistently. It's a robot, and then the instructor can focus on instructing and figure out the best way for that student at that time. In doing so, we're both creating rubrics and we're creating outcomes. And that's what's really helping both the students have a better training experience, but also the instructors who had to run the simulator to focus more on what they're good at, which is instructing. As much as that is can be automated, is something that we see be proven to be a very big benefit for both the student and the trainee. And that's something we spent a lot of time making sure we can put in, but also tailor as needed to different students. Okay, so that's a bit of a ramble on some of the studies we did, and I'll if anyone wants to contact me, we got more we can talk about. And now I'll move on to some of the things. How do we take the outcomes of those studies to create a better training experience, and as our ultimate goal is, how do we make people competent for the job that we're expecting to do? And we'll use the old adage, as much as we can get people in an environment where they can train as they're expected to perform, or train as you fight, that's what we see being the most beneficial thing for students as they're in these environments. So as much as we can make the scenarios realistic and something that they're actually going to have to do in real life, as much as we can make the environment immersive, so it feels like they're in a real lifeboat or real emergency. As much as we can give them the hands-on approach where they can get the muscle memory and reach out and touch things, so that it becomes a routine as driving your car, even though you don't drive these cars, these lifeboats every day. As much as we can build those features into the training environment, the more they'll get the muscle memory and be able to draw on experiences that they had in training when they actually had to respond in a real emergency. And that's been a tried, tested, and proven application in a number of other industries, including flight, military, and medical, and such. And bringing that to the marine world is really something we see being a big benefit. The other thing is making the training accessible. We've mentioned before is giving people the ability to practice and retain and maintain their skills is a big benefit. And the more they can do so, even if it's just refreshing their minds of, here's a procedure I have to do to launch a lifeboat, and have that hit them in the face as frequently as possible, that's where we'll see those skills be maintained, and again, to keep them fresh for when they actually had to perform, which hopefully is never, but could be possible if they got to launch from a lifeboat from a sinking platform or from a vessel that's on fire. We never want that to happen, of course, but when it does, we want them to be ready. Next slide is, and this is something that we take to heart quite a bit. And I know it's a bit of a busy slide, but basically, as much as we can embed our lessons learned into a curriculum and design a training experience where the competence matches the learning objective we're trying to put forward. And I know it's a loaded question, but it's a new challenge. And anyone here who's in training, of course, the importance of defining good goals, good objectives for the learning objective you're trying to achieve. But now, if you've got a clean slate and you can put people in environments that are that they're actually going to be in, such as an emergency and such, what would you do as a trainer to put them in a situation that you think is realistic, and get them in a mode where you think that they're going to have to perform by getting them engaged and getting their heart racing and giving them a little bit of stress. And that's the stuff you had to be able to vary as an instructor, as you know, to make sure it's a good learning experience for the student. So you're going to cater to a novice more than you are to an expert. And there's things you can deal with in the curriculum and the course design, but also in the scenarios as you implement them, to change variables such as how much information people get, how difficult things are, how realistic you make the scenarios, how you make people fail, these sorts of things to cater to the different skill levels. And this has been an iterative approach for us ever since we started building these new scenarios for lifeboat operators. Is we embed as much as we can at the start of our curriculum to set goals for people at different levels. We play with the gameplay through different types of coaching, different narrative, different types of feedbacks, different types of learning styles, whether it's do this, do that, or then go figure stuff out on your own through exploratory learning. These are things you can play with in the learning environment. The outcome is where we really learn, did our training actually work? And that's where we take the outcomes and adapt our, not just the curriculum we had in place to make our curriculum better. And we're by no means going to say that our first guess at the curriculum is great. But we have learned, as more people use it, that there's tunings we make to our curriculum that makes it better and better and better. And that's the stuff that we pass on to anybody who's using the training, is that there's a lot of expertise built into this. There's a lot of information that students built into the curriculum. And we keep this as iterative a design as possible. And as much as we can embed outcomes from performance to an expert's opinions, and also new information that we have about performance requirements and such into our curriculum, this becomes a better learning experience, with the ultimate outcome being a more competent trainee. So in doing so, maybe we just keep this as active a cycle as we can. As we get new information, we get data from our clients, and work with our clients as regularly to get information about what training scenarios are working, what training outcomes are they having the most problems with, and then we adapt our training curriculum to meet their needs. And that's really something that's easy to do, especially when things are being captured digitally, and also something where we can, for example, we can change the scenario back at one officer, or instructor could change the scenario and upload a scenario to a simulator, and something like a scenario gets just changed in 5 minutes, as opposed to having to redo a full curriculum design. And the last thing is we focus on the journey of the trainee as they get into a simulation-based training course. We're not going to hide one thing is that we're trying to make this as much as an engaging and gaming experience as we can. There's lots of good lessons and games about how do you keep people immersed and how do you keep them wanting to keep coming back and do their training. And the outcome is they're actually getting better at what they're doing because they're immersed in their environment. But we start them at the bottom of this hill, which is, first off, getting to realize that this is a job they have to do. So when we bring people into a training curriculum, we get them to we try and get them to the point where your job as a coxswain is to take the lifeboat you're about to get in and save the lives of the 80 or 100 people who are in that lifeboat. So we give them as much contextual relevance as we can to get them bought into, this is a job that I'm actually expected to do as a lifeboat coxswain. And then we bring them up into our training world and put them through different training regimes, whether it's course material or simulation, and get them to the point where they're engaged in the environment. Their heart's going up a little bit, but not enough that they're challenged, but they want to keep playing. And that's something that this is obviously a dial we got to change back and forth depending on the level of expertise of the trainee. It could be, this could be a novice person going through a training course for the first time, and we might have to take down the challenge. Or it could be an experienced operator who's got 25 years marine experience, who's trying to tune their skills and wants new scenarios that even the most difficult or even the most experienced person would have challenge with. But either way, they want to keep doing it because it's fun and engaged experience for them. The ultimate outcome is them having both the competence and the confidence that they can do what they need to do in an emergency. So we start with here's what you have to do, and we end them with, you can actually do this. And getting them in that mode is that's our sweet spot, and that's what we believe to be the best learning experience, where people can really want to come back and do the training, but also see the outcome as being, this is not just a training course for me. This is me really having to really challenging myself and giving myself a new skill that I can apply when needed. Okay, I just want to show one video of what one of our scenarios looks like, just to show, and this is just to show what a scenario is and how we've embedded some of our scripting and some of our instruction into this. This is a novice scenario, so we got lots of coaching going on here. And this video starts when someone's gotten through the backstory and knows that they actually have to come in and do a drill. And then we're going to put them in a simulator and get them to practice that drill. So we start with, open the door, you get in your simulator, make sure everything's reset. Then when they actually get in the simulation, I will head a bit here now. They're given their objective. They're given some radio controls of what they actually have to do.
Lifeboat 2. This is control room. Read you loud and clear. Out.
It's just like
this is the Torbay Explorer Bridge. The installation's MOB drill is about to commence. Deploy Bridge Rescue 1.
So in this case, they're going to do lots of a lifeboat, and then they're going to go pick up a man overboard. I'll show you. This is a very coachy scenario where we've given them lots of pats on the back and saying, here's what you have to do. But as you can appreciate, if this was an experienced coxswain, we wouldn't have to call the water so calm, and we wouldn't be giving them so many hints. So I'll just I'll go to this point here where they're actually launching the lifeboat. And as you can see, they're getting.
So already, start your engine and warn the passengers that you are launching. Pull the brake cable and do not let go.
So they'll go through a launch. They'll be given coaching all the way down. This is really,
remember to mark your bearing once in the water. Once free of the fall wires, put the boat in gear and then continue.
The other thing we'll do, when they get in the water, you'll see something happen. There's a fault. There's an equipment fault that they have to overcome. So right here, I'll stop it. They've actually had a hydrostatic interlock problem, And now that student, this is the first time that they've had to deal with this problem in a training scenario, but they do it here, and they just he doesn't pull the safety pin and use the hydrocyte override, and they're done. So this is a very coachy scenario, meant to be. If I showed one without all these prompts, it would be hard to talk about what's actually in there. So I did the latter. I did the obvious and showed the prompts. And then when we put them into a scenario where you had to recover a man overboard.
Okay, coxswain, bring the lake and come downwind. When you get close, let the assistant coxswain know on which side you want to recover the MOD dummy.
And they're also told how to do it and give us some coaching. So again, we could vary the difficulty just by not having as much coaching in. And I'll move forward to when he actually does the pickup, he or she, I guess, and the operator here does it very well. They come slowly upon the man overboard. We get them really close to the port side of the lifeboat, and they stop and maintain the speed so that lifeboat and the man overboard can be picked up. And there you go. So that sounds like a simple exercise, but the instructor there also had to measure four different things at one time. And the simulator just does it automatically, and that's where that's something we highlighted earlier as being one of the big benefits of this. And that's what a scenario looks like. It could start as something as simple as this and progress to someone having to launch a lifeboat from an 8 or 10 meter or 6 or 7 meter sea into a platform that's being that's listed to one side, and then having to pick up a person's water. In those sea states. So you can imagine how stressful those environments can get. So I just want to summarize what we talked about here today. This is what we see the training experience being. First off, starting with what the learning objective. We want to make sure we put people in an environment where the scenario is real and they're getting access to real equipment to do their training. And make that environment as immersive as possible. As much as we can automate the assessments or get the simulator to do the work, that provides a consistent way to do assessment, but also reduces the workload for the instructors when they're doing so. And as we do those exercises, we're capturing data to model human performance. And this is a critical point now as we're putting people in situations where a whole lot of data, there's not a lot of data existing for these types of students. And that's helping us model what we think is expected of experts and novices in these situations, so we can adapt training accordingly. And this can be done through instructional design, or it could be done through things such as machine learning, where we can adapt the training on the fly, which is something we can talk about at a later date, but something we're very active in as well. Well, ultimately, we're trying to get this gentleman here home to his family and his kids, and make sure they, in the event of emergency, they're safe and they're smiling, and giving them the confidence that they can do so when needed, and again, keep them safe so they can go home and kiss your kids goodnight. And that's really what's driving us. And we as much as we can enhance learning experience to make sure people get to that point. That's what we'll contribute to this environment. And that's it for me, Allison. Thanks so much for your time, guys. And if you have any questions, feel free to chat. And Allison, you can take back the mic.
I will. Thank you, Randy. Just to make sure you can still hear me okay. Okay. So thank you, Randy. I always enjoy learning more about this. I think I learn something new every time we talk about it. But we do have a question, or yes, we do. I'm going to just make it a little larger so I can read it. This is from Clayton. He does say, thanks, Randy. Very informative, interesting comparison between drills, CBT, and simulation methods for skills transfer study. How effective have these studies' results been in swaying market opinion toward greater adoption of simulation?
They've certainly been used. So a lot of the things that we've had to do is obviously provide evidence that the training that people are getting in a simulator is as good as or effective as what people are getting in live training and such. And in addition to some of the studies that we talked about here today, there's been lots of studies about simulator effectiveness and transfer studies in equivalent conditions and in like just calm water and such. As you can appreciate, there's not a lot of evidence around people performing emergencies. So what we found is as we share our results, with regulators or with clients or with even trainees who are interested in these performance, that it normally begs more questions. Well, why haven't I received this training? Because there's an alternative available. And it's also swayed some of our clients to say, well, if there is an alternative available, it's not just extends the limitations of training, but provides a way for people to augment or get more frequent training, then why aren't we doing it? And that's become a big pull for us right now, as people are seeing this as a form of alternate compliance. And it's got to say, it's been a big driver for us in our industry right now.
Absolutely. Thank you, Randy. And thank you for your question, Clayton. I think you might have another comment there. And in the meantime, it has, I can say from a sort of a team perspective, during the COVID-19 situation, it has also been advantageous, of course, for those trying to keep their skills current and to, remain certified and keep their skills up to date and their competence high, that we've had a lot of discussions and a lot of further movement on those who have been thinking about simulation and now moving to e-learning and more simulation. So I think Randy might agree there that that has helped sway the market as well, along with the studies.
Yep, sure has.
Mm-hmm. Okay, we'll just give Clayton a moment to type a question or okay. Okay, it's a comment, but I will read aloud. So we have a recording. Thank you, Clayton, very much. Agree with the increasing system assessment measurement functionality. This is critical for freeing instructors to coach and also to create an empirical and consistent performance measurement standard. Good stuff. And I would say we agree.
I do. It's really been an eye opener for us as how much people enjoy the coaching part as opposed to the assessment part sometimes, just the measurement part. So coaches are good coaches are good coaches.
Absolutely. Okay, so I don't see any questions coming just yet there. So we'll aim to clue up. If there's, Randy, did you have any final remarks that you wanted to make before we clue up?
Other than we're skimming some of our studies here. If anyone's got any interest in talking about anything you've seen here, reach out to me or Allison, and we've got some. If you want to go as far as publication, we can send you publications on some of these things. But if you want to reach out and have a chat about anything you see here, and actually, we'd love to hear from you guys. If you got input, good or bad, as you can see, we're trying to be better every day. And if you think there's things we can do better, we'd like to hear that too.
That's great, and absolutely. And so I'll finish up. Thank you very much, Randy. I think this was great for our attendees and for our recorded guests that will be picking it up later. Again, it will be available by recording. So please contact us and let us know if you would like us to share the link to that. We will be hosting another webinar. The final of our 4-part series will be in 2 weeks' time. So please have a look out for that webinar coming up and get registered for that. I do see someone is typing, so I'm going to sort of delay for a second. I am going to turn off the recording here now, but we can still continue. And so thank you everyone for attending. You don't have to pop